So let's start. Yeah. First of all, hello everyone. My name is Aleh. I'm backend technical director at Strikerz Inc. So I lead the development of UFLs, backend infrastructure, ensuring a smooth and scalable online experience for players worldwide. So we are using cutting-edge technologies like Google Cloud. And I'm super happy to be here. So yeah, and give a talk about UFL. It's actually first talk about UFL on technical about technical things.
Hi everyone. My name is Matas. Labas visiems. My role is customer engineer at Google Cloud. So usually I am working together with teams like Strikerz under the game UFL. We are working together on various technological things where Google Cloud can help the game to be fast, popular, and provide best possible experience.
Okay, let's first of all, I would like to ask you guys, have you heard about UFL before? Raise your hands. Okay, great. Not so much. All right. For those who are not familiar with UFL, let me explain some things. UFL is a free-to-play football video game focused on providing a fair, skill-based experience for players. So it allows users to build their football clubs from scratch, from real football players, and compete in online matches, and without pay-to-win mechanics. So it's cross-play, is running on Unreal Engine 5 and supports consoles, PlayStation 5 and Xbox Series X and S, and in the future will be on PC, on Steam. So our philosophy with UFL is simple, fair to play. We committed to eliminating pay-to-win mechanics and other options like that, ensuring that success is determined by skill. So not by how much money you will spend. So UFL is about fair competition where players can join at any time and on an equal footing. So football legend Cristiano Ronaldo, our co-investor and UFL's key brand ambassador announced late last year. He was joined as a part of a group of investors committed to raise about 40 millions for development of our title. So the game already conducted two open beta tests and one common test. It's a reason for anyone to know about that game and have had a chance to play it. So, and during that open beta test, common test, about 2 million people played UFL. So the game release date is scheduled for December 5th, 2024. Early access will be available starting from November 27. So available on consoles, as I mentioned before. So join the game, not so far from release.
And another important part of whole game is to make game scalable, you need infrastructure which allows you to do it. Yes. So game already showing a huge success on open betas, and we are partnering with Strikerz on this game as Google. And important part that Google knows how to run scalable applications. Yes, 10 applications in Google already has more than 1 billion users. So we have infrastructure and knowledge how to run infrastructure at that scale. Yes, and via Google Cloud, we are sharing that infrastructure. So Google Cloud allows and powers the game on the backend side. So a lot of technical details will be covered a bit later, but in general, Google Cloud allows the team from Strikerz to access that infrastructure and technologies available to power these powerful applications with more than 1 billion users.
So let's move to the topic. Before we need to define some things to be more clear. So what makes a game an online game? Pretty simple things like player data management, storing progress, stats, game data, and everything about that, like quests, I don't know, events, some ladders and so on. The next one is some social feature like a chat, I don't know, leaderboards, clans, tournaments, and things like that. And the most interesting part for us, it's of course online matches between users. So it's multiplayer matches online, which makes most of games online. So what are the challenges here? First of all, store player data, process that, and do other things with player data, which makes it available across all players and devices to get access to that. So next one, for matchmaking, we focus on balancing factors like skill level, location, availability to create fair matches. Because if you play online games, you know how it could be when you have a better skilled your opponent, and we would like to eliminate that things. Low latency gameplay. We understand that it will be online game. We need a network, and we need to understand how to make network connectivity is the least painful part of our game. Of course, scalability is key to handling player load function. We need to efficiently scale servers to ensure the game runs smoothly, even during peak times. And I will add something about that in the future. And of course, last but not the least, security is crucial also for us. We need to protect our game from against DOS attacks, hackers, cheaters, and other things here. So protect players' data and something like that. Before we go deeper to technical stuff, we need to ask you, do you know what Kubernetes is? Raise your hands. Oh, it's a good one. Okay, great. And are you familiar with the concept of dedicated servers? Great one. Great. So, yeah, a bit more about Kubernetes.
So, as you already know about Kubernetes, and if you haven't heard about it, it's a technology which is currently available on the market. It's open source project. To be honest, it's second most popular open source project in the world. First one is Linux, and there is Kubernetes. So it's really powerful technology. Kubernetes was born in Google. Even back in 2003, Google have been running all infrastructure on containers. It wasn't popular yet. It wasn't Docker time, but Google have been scheduling applications on containers. And later in 2015, Kubernetes, with all experience gathered inside the Google, powering these applications like Google Search, Gmail, and similar, have been selected and open sourced as Kubernetes in 2015-14. And it was added to Google Cloud as Google Kubernetes Engine, managed version of that technology. What that technology is doing? That technology allows you very easily to manage applications which are running in container or pod. It allows you to scale and to keep up the infrastructure to power the workload similar like gaming. Yes, in gaming you have seasonality. Yes, all across the globe there are seasons or daytimes when, in example, in somewhere in the East, in Japan, the people are waking up, starting to do the job. Later it goes to Europe and later to United States. So you always sell infrastructure, it's up and down depending on what is happening. And Oleg will share an interesting story that not only daytime is impacting it, but also some other interesting factors.
Yeah, but it will be a bit later. Okay, let's consider what how our players can interact with each other. First type of this interaction, there is lots of them actually, but the simplest one, it's like client host. So there is some clients connected to the host, which is also client. So it's a lot of advantages. First of all, the biggest one is a low infrastructure cost because you don't need to manage dedicated servers and something like that. So the second one, it's in some cases it could be a really good one choice for a group of players who, for example, in one room or in one city, because it's give the lowest latency as it possible. So next one, but there is some challenges. Of course, it's a cheating if you give control over the server of your game to the players, they will cheat. It's not a chance, it's definitely will be so. There is some connectivity problems because it's a NAT problem if you're familiar with that. It's not easy to connect sometimes to the host because you need some infrastructure over there. Of course, it depends very. There is lots of things about bad network, because if host has a bad connection, bad internet, the other players will suffer from that. So, and host scalability, yeah, you can't scale host to produce to process more games. So the next part it's about dedicated server. Why we think it's better for online gaming? Obviously, we can control dedicated server. So it allows to protect from cheating and other things. We can reduce latency because we control where dedicated server is located. We need some data centers, Google data centers, which working on network connectivity and make the experience much better, and we understand the performance of that dedicated servers, so we can achieve some stability here. But there is a challenge. The most challenged thing, it's infrastructure costs. So you will pay a lot for that, and you need pay a lot for infrastructure maintenance, not so much as it was 10 or 20 years before, but you need some DevOps and people like that to make it possible. And you would like to utilize instances where dedicated servers will run on the highest peak, so 80–90% of usage, and make it possible. It's a pretty challenging thing, so performance is very important here. And of course, scalability. Sometimes we need one node with dedicated server, sometimes we need 100, 200, and 500. 500 nodes overall. So with that, things goes deeper, and we start with the simplest thing. Very complex and difficult scheme about how we manage things like storing player data. We have services that handle a majority of work related to authorization to the metagame, like managing clubs, purchasing players, stadiums, and more. These services are written in Go, and all they require to function is actually database. And data management and some social feature is done by the same services. So, and remember the recipe of success: put everything in Kubernetes. So it's not a complicated thing, but we really put everything in Kubernetes. We run on Google Cloud in GKE. So some several load balancing, and some managed services provided by Google Cloud to manage some data, like Cloud's SQL and memory store. So remember that scheme, put everything inside Kubernetes. The next thing is matchmaking. As I mentioned before, the goal of matchmaking is to pair players with similar skill levels to create balanced, fair, and enjoyable game experience. So we need to ensure that players will be happy about play, about matches, about their opponents, and we need to reduce frustration after matches when you got 10 goals in one on one side. So yeah, and we need something in the cloud to make it possible. So to put our players on compute engine. So let's consider the scheme. Pretty simple also now. We have service, it's called match frontend, and our client sent a request for that, and we request to join some matchmaking. We need to understand who is it, their skill, some data from previous matches. We need to their location based on latency, which we measured on the client side. So we understand how far he from some clusters, and we need to understand skill and some other things like a platform. Is it able to play with other platforms, because there is some regulation about that. So we did it, and we created things like it's called ticket. So ticket describes everything about matchmaking, about that player, and about their desire to play in some particular, for example, game mode, ranked, quick, or something like that. So what is open matchmaking or open match? Open match is open source game matchmaking, developed by Google also. So, and it's eliminating everything, every complexity about scaling, something part of that. So what we need to do, it's only write some rules how to match players. It's not so complicated rules, because at that moment we need to match only two people. So, but it's still complicated. In some cases, you need to match 15, 20, 50, sometimes 100 people. So, and OpenMatch will help with that. So we wrote some rules about that. It's called match function. And we have a service called match director. And match director asks every time open match about, do you have matches? Do you have matches? Do you have matches? Every time. So every seconds. And open match trying to make that pairs of players make a matches. When we got a match, we understand. So okay, that player, we need to run game server for that. And we ask Agones, it's another tool, give us allocate game server. So Agones, it's also open source tool developed by Google Games, Google for Games, yeah, and it's open source, dedicated game server hosting and scaling solution built on top of the Kubernetes. So it brings several benefits. It can pack game servers on one node. It reduces waste. So if you have 5 nodes, it will place in some free spaces to give best cost-effective in a cost-effective way. So it will allow to easily deploy game servers in any in right places in right time, and it's actually engine agnostic, so you can use it for Unity, Unreal, Godot, or what else. And there is some other features like some monitoring, logging, things like that, which help to control your game servers during the production. So yeah, and you know the rules, put it everything in Kubernetes, so it's running on Kubernetes. Final scheme. So Agonos at the end give us allocated game server on some destination, and we have that game server. We know his address, IP, port, and we deliver that to the user, and user directly bypassing our backend connect to the game server. So, and match is started. So, and the rule recipe of success, put everything in Kubernetes. So we have two different types of Kubernetes here. We called it two different types. One, it's a meta cluster, where is authorization, matchmaking, metagame services, or something like that, and game server cluster. And there is a lot of game server cluster around the world. So at that moment we have more than 20 game clusters around the world, and we need to actually decide in which location do we need to allocate game server. So match director do that. Not match director, open match do that based on latencies which are provided by client during join request. So we know, okay, this is player is the nearest cluster is, for example, Frankfurt. So let's allocate here. Let's find first of all opponent here. So because of that, because we are running globally, we need a lot of clusters around the world, and there is why we are using Google Cloud.
So, talking about this setup, we already know that we have technologies to make possible, yes, connect players, find players, etc. But also we need technologies to power these dedicated servers. So here, Google and Google Cloud with its extensive network comes into play. Because through Google Cloud, we allow our customers, including Strikerz for this game, to use Google backbone networks, undersea cables, and all infrastructure for that experience. What it means, when you find two players, these players have the shortest path possible to connect to game server, because based on BGP technology, these players using their home internet connection gets nearest Google data center, located somewhere nearby. And you know, we have a lot of data centers all around the world to power YouTube, Google Search, Gmail, etc. And then, using Google backbone, travels to game server location, which was created by GameOn. Yes, so this is the best possible experience which you can get from a network part, because in most cases you utilize only dedicated cables, including cables undersea, which are powered by Google. Yes, and one slide back. Yes, and also we have currently more than 40 regions, so most likely you will be able to spin your game servers as near as the users are playing. Yes, we are covering a lot of large locations all around the place, and later Aleh will show how their map is looking, and we have done some mapping around that. Yes, and when we come inside the data center, we also have very powerful network. So the latencies between services inside Google Cloud also are communicating at very, very, very fast network connectivity with low latencies. that also improves the game experience, because no one likes to have a game where it is lagging and experience is broken. Yeah?
Okay, now that infrastructure is in place, clusters are set up, we need to ensure that our solution can handle required loads. Actually, we have a specialized set of tools to make that possible. This is both interesting and complex challenge. Figure out how to generate the right load, how to create appropriate load profile, and more and more and more. But let's say that we managed to do all of that and follow the simple rule. So running load test, analyze this, what's going on, fixing, deploy, and repeat it forever. So every day, every time. But is it really working? So to answer this question, we conducted open beta weekend, actually several open beta weekend, some and one common test. And for first open beta test, we got some results. We conducted the goal of the open beta weekend was test our infrastructure, our backend, our game under real-world loads, collect enough data of user behavior to understand what's going on, and of course gather valuable feedback about game itself. Is it enjoyable? Is it fun? Understand how our matchmaking is working. So there is we gathered some significant amount of data of user location, internet quality, and the popularity of various region. For example, we understood that we do not have region in Australia. So, and next time we managed to launch it in Australia. So everything that we collect provide us valuable insights. To understand some server location, as I mentioned, redesign internal interfaces, and tune a bit our load test profiles, and of course fix a large number of issues. All of this has resulted in a significant improvement in both games quality and user experience. So, and the funny part, during the open beta weekend, we got some unexpected behavior, which makes us pretty nervous for a while. And the answer was Cristiano Ronaldo, actually. We experienced a significant surge in players after Cristiano Ronaldo post. So at first we thought it might be a DDoS attack, but it turned to be a great opportunity for us stress testing our system under real world condition. So yeah. Future, yeah, come on. And we have some things in the future which we would like to make together with Google Cloud. So.
Yeah, so first of all, after reviewing and getting results from beta testing, as Aleh shared, there were some locations which doesn't had a dedicated game server. So these players have been matched and played the game, but maybe had a bit bigger latency due to the game server being quite far away. So that's why we are reviewing, together with our customers, in this case with Strikerz, we are reviewing our map of data centers and locations with the player behavior and player map. And an example, as Aleh shared, we have data centers in Australia. So for them, it was really easy for next open beta just to launch these game servers in Australian data centers, and that's covered. What wasn't covered, but it's coming, in example, Mexico. Yes, in Mexico, there are players and a lot of players, but currently we don't have a data center there yet. It will be soon launched, and once it will be launched, I believe Strikerz will be one of the first customers utilizing the power over there. Yeah. And another topic which was also important, we were lucky that it was Cristiano post, but not real DDoS attack which attacked the infrastructure. But that gave us additional talks about how we can secure that environment, which is running globally all around the world. Yes, and in that case, Google Cloud has a technology named Cloud Armor. It's distributed anti-DDoS protection, web application firewall, and in general, security system which allows to secure a lot of applications which are available online. I think last year we protected one of our customers with one of the largest DDoS attacks. So next slide. So that attack in 2 minutes generated so many requests as Wikipedia is getting in 1 month. And our technology protected the customer infrastructure from that attack. And it is possible because we have extensive network. When DDoS is coming, we have data center servers all around the world, and all of these are coping with that attack. So for attacker to go through that network, they need to be really big. Yes. And another part of our collaboration together is what's coming next. Yeah, so the game will be released, it will be improved, but experiences are going to change, yes? So what we are coming, of course, artificial intelligence, how we talk about it. So currently we are at the state when we have live games and we explain how these live games can be implemented. Yes, what's coming next? Next is coming games where the players will be able to change the game and get personalized and creative experiences with AI. And an example, in Google we have a technology, Gemini. This is a model, yes, multimodal model, which allows to generate content, audio, video, text, and similar context. And these technologies can be integrated into the game experiences. It's up to you what you're going to make. Either you will make creative players inside the game, either you'll be creating new stadiums, either you'll be creating new experiences, ball forms or whatever. That will not require, someone in the backend, in the design phase, writing and doing the templates of something. You will be able to create it online in the game for your experience. That is what is coming, and currently we have technologies which are able to do it, but we need to adopt that. And important part of adoption is that while choosing partner like a Google, you are quite ahead. We already have been playing with AI for some time. And we know how the AI is interacting with online, web, and network applications. That's why we already have architectures and technology which are able to integrate what Aleh has said in Kubernetes and whole ecosystem in matching. And the next step you need to do, you need to be creative and just try to add that technology to your game. This is the future of gaming, and most likely we will face it very soon, or already facing in some places.
Conclusion. As we mentioned about UFL, yeah, it's an online game, competitive online game, football, like a football game designed for global audience, and to ensure we meet the demands of global audience, we rely on Google Cloud for scalability, which help us to handle dynamic players load, especially during peak times, as I mentioned before. Continuous testing, including beta tests with real players, is crucial for us. So, especially now, there is some tests, but closed test is conducted. So this test allows us to refine our infrastructure, gather feedback, and make sure we deliver the best experience as possible. Open match help us to ensure fair and efficient matchmaking by pairing based on their skills and lots of other attributes of player, properties of our backend, and so on. So, and finally, to manage our dedicated server efficiently, we use Agones and Kubernetes and GKE service for that from Google Cloud. So, not last but not least, but not last but not least, security. It's also key for us. We need to protect game from attacks, ensure privacy of player data, and Google Cloud will help with that because we store in managed services of Google Cloud like Cloud SQL, Memory Store, and other things. So, and actually our collaboration with Google Cloud is very good for us because it allows us to innovate and incorporate valuable feedback from players and do not think about some deep technical things like managing network data centers and things like that. So it helps us to focus on game itself, not technical things like that. So yeah, thank you for your attention, and yeah, thank you.
Thank you.
Do you have any questions? I can start, I guess, to maybe to encourage.
Sorry, I have a small prize for
That's
the most interesting
thing.
question. So be active, ask something.
Now it works.
Okay, please. Yes, motivation.
I thought to ask it privately later. Okay. You mentioned fairness of the matchmaking, and based on my experience playing another football game, better I play every time, worse connection I have. For example, lots of time I play against South Arabian players who has maybe very far away from me. And it's very important for me playing the competitive part to have a good connection. And is it EA Sports didn't solve this problem? Still didn't. Still have this problem. What the big difference of in your game to solve it? Because every time playing Weekend League, I struggle playing with low connection with my opponent, and I don't know, is there any architecture differences in your game to solve it? Because it's, for me as a competitive player, it's the most valuable thing. Thank you.
Yeah, good question for that. There is no. It's not about architecture actually. It's about how we write rules to make matches for you. And you, as you mentioned, you are a competitive person, and maybe you have a really good skill in football simulators. And higher you climb to the top of players, it's become harder to find a right opponent for you. So, and it's a balance. Would you like to have a guy with the same skill from Saudi Arabia or something like that, or you would like to have best latency? There is no right answer. It's a balance. Sometimes, and it's like game design things. So sometimes you can play with guys from Saudi Arabia, but in our case we are using a dedicated server. So there is no chance that you will get you will play very far from your location. So there is no chance that you will play in Australia region, because we know your latency. There is no chance for that. So it's a bit complicated question to express, but there is a balance. So try to do the best only that.
Thank you.
Hello. I have a question for the Google side of things. We are currently developing a game. It is a multiplayer game with large amounts of players. We're currently using AWS mostly. I would love to hear like main points, advantages of GCP over AWS, if possible.
You're pushing me to this, yeah? Yeah, so it really depends, but I think what is well known and we are trying to do, we are contributing a lot to Kubernetes, and if you power your game with that, most likely you will have most advanced and needed things regards the scalability, how the things are working together, and how much effort you need to invest into that. But we can discuss it later about it specifically.
Yeah, we should turn the camera off.
Thank you for the talk.
Yeah, thanks. Do we have more?
Was this your first project working with Google services as a company or personally?
With Google, yeah. I have before Strikerz another company which already mentioned before.
My main question is, what was the learning curve using new technology by Google? Was it hard? Did you find the documentation or customer support enough? And maybe you found something that was really easy or quite hard to do with that technology?
Yeah, also great question. Actually, from my experience, if you know a cloud technologies from one provider, you know it you partially know everything in another. There is a lot of things and services which are working partially the same. So the best what I can say, my advice will be know the basics, know the rules how to play. So, and you don't need to think how it's working on a Google Cloud, on AWS or other providers. So, but of course, if you goes deeper, we're talking about Kubernetes put inside. It's not a silver bullet. Deeper you goes with your game, with technology stuff, you need to know a lot of things. So. What I can also advise, there is some certifications which can help you to understand lots of things about some clouds itself. So yeah, and there is also good documentation about everything. So yeah, and but anyway, we collaborate a lot with Matas, with other guys from Google, and I would say that a lot of things in documentation, but it's still projects. We need to clarify some things and understand, give our feedback to Google team that, okay guys, we need that one, that things and that things, but it will be a bit further. So, did I answer the question?
Yeah, thank you.
Okay.
Thank you. Do we have more? Or yeah, let's see.
Thank you. We are developing a game in Lithuania, and we're using browser-based game, and we're using another three-letter cloud provider and Docker containers. And we have a problem with latency. Maybe we have some formula of success to overcome problem with latency and our Docker containers.
It's a complicated question because what do you mean about when you say latency? It's a network latency or it's input lags or something like that?
I bet it's a combination of backend engineers doing the code efficiently plus the network latency.
Okay, so yeah, if we talk about let's say RTT, so latency from server and back. Actually, there is no silver bullet. You need to test everything. You need to understand the backbone, how your traffic is delivered to the user, and actually, it's not a case about Docker itself, I think. But there is a lot of issues with that. So let's start with understanding what's going on. I mean, from game server to the client, and back. Try to do it without Docker, because it's for testing purpose. It's not necessary at all. So yeah, there is no silver bullet. There is lots of things to do to test it. You know, like do that, get some results. Okay, it's not a case. Do next, get some results. Okay, there's some issues. So yeah, did I answer?
I thought maybe put it in Kubernetes.
That's obvious answer, yeah.
Yes.
Okay, maybe it's time for you to tell about the price.
I suppose you had a question also, no?
No, I think now it's more like an invite to do a next talk. I would love to know more about the game itself, about the team, about the creation. But that's, I think, like the 1 hour talk. So hopefully we can invite you after the game releases and find a place where you could share that, because yeah, it's a very interesting thing to know. And yeah, I think you can tell about the price and how do we do it.
Tell about what?
The gift or
okay, price. Yeah, I like question first one about matchmaking, because that question is inside Strikerz. We can't answer that question in a because there is no right answer for that, and I like that this person asked me for that. So yeah, it's a hoodie. So yeah.
Oh, nice. So if you have any comment more or anything?
No, thank you, community, to listen us. Thank you.
Yeah, thanks a lot. Hope to see you after the release and have a successful release.
Train.